Okay, so let's define a list. L is equal to 3, comma 1, comma 4, comma 1, comma 5, comma 9. And I just remembered another one over here, which is count. I'm going to go back to my list functions and put x is equal to L dot, but just L dot count x. Count is definitely in there, so scribble that into your list. Okay, so we have a list. Let's find out how many ones are in the list. Ones is equal to L dot count, like that. I want to find out how many ones are there. Well, how many are there in that list? Yeah, there's one. No, there's not. There's more than one. There's 2 ones. Okay. If you specify a number that's not in there at all, it'll return a 0. You know, if I looked for 8. Let's sort that list. L is equal to sorted L. Sorts the list. And print that list. And it'd be okay for y'all to actually, you know, this would be one form of note taking if you actually entered these into idle, but you don't got it. I'm going to call this one very creatively April 12. And what have I done wrong here? Come on, guys. Y'all let me make an egregious mistake. How do you define a list? Yeah, square brackets. That does something completely different, what I just did there. It defines something called a set. And a set is an unordered list. An unordered list means it has no order. You may have taken like a discrete math course or something where you do sets and you can take the intersection, the union of 2 sets, or you know, that kind of stuff. We kind of skipped over it. If you ever have to look it up, you could. A lot of the functions work the same. Some of them don't. Anyways, let's give that another shot. There we go. That's the data sorted. Awesome possum. Okay, if we want to print a list, there's 2 ways to do that. There's what I have been calling for each, which next semester I'm going to rename for in. And then there's the other one, which is for in range. Let's just do for in first. For, and since these are numbers, I'm going to make it N or I. If they were strings, I would make it S. That's just optional. You know, you could pick Fred or, you know, whatever. Michael Myers, you know, whatever favorite variable name is. Okay, so for N in L, print N. I was calling that for each. I'm not going to use the term for each on the exam. Then you could also print it using its index value. What does index mean? Well, that's when you do something like this, right? So I want to print something out. I want to print the entire list out using indexing, which means I need a counter rather than a temporary variable like this. This is a temporary variable that gets filled in with each item in the list. So first n is equal to 3, then it's equal to 1, then it's equal to 4, then it's equal to 1, except that we already sorted the data, so that's not true, but you get the idea. So, and for in range, I'm going to use I for index. For I in the range of the length of the list, kind of a hairier syntax, print list item at I. Don't leave, come back. Alrighty. Make sure that runs. Hell no, it doesn't. It's not for n equals L, excuse me. It's for n in L. And we've typed that a lot, so I hope you don't. I did the same mistake there. My brain's broken today. Cross out those equals, replace them with the word in. Alrighty, that printed them out 2 times. That's what we wanted. That's an example of printing the list, 1 per line, using 2 different for loops, including for in range. Not rage. We're not that upset. There we go. We'll go back and we'll cover range a little bit more, because remember that there are a couple of different possibilities for range. Like if you wanted to count from 1 to 10, or if you wanted to count from 10 to 20 by 2s and all that kind of stuff. Alrighty, let's insert a new item into the list. L.insert, and I want it to be at the very beginning of the list. I'm going to insert the value 100 at the very beginning of the list. The first parameter indicates where it goes into the list. 0 meaning that it becomes the new first item. If you put a 1 there, it would become the new second item. Let's print the list out to make sure that our 100 is indeed at the beginning of it. And it is. That inserted the first item. Let's remove that item. There's 2 ways. We could use L.delete, DEL, specifying index 0. That would delete the first item. Or you could do this, L.remove 100. That searches a list and finds it. But we don't have 100 anymore. Honestly, I don't remember what it does, if it generates an error or not when you try to remove something that doesn't exist. Ow, come on. When you're calling functions, you don't use the indices. Now, honestly, if you mess up and you use parentheses rather than braces, I'm probably not going to count off big time. As you can see, I make the same mistake. Okay, that's not how you use delete. Oh, for Pete's sake. And you knew this and you didn't tell me. It's actually delete list item 0. That's why I put those. There we go. That would do it. Honestly, I don't ask about that for some reason on the exam. I mean, I could put it on there. This is the way that I do it. Make sure those syntaxes work. Nope. It said X is not in list. So if you're trying to delete something, you might put it inside of an if statement. That would look like this. I'm going to comment that out. I want to make sure it's in the list. And that's the very first thing I did here. This checks to see if it's in the list. If 100 in the list, L.remove 100. Else, print. Couldn't remove 100. It's already gone, so that's why we got that error. This is a safe delete here, you know. It checks to make sure it's in the list before you call remove. This is an example of that very first one. SNL, you know, if value is in the list. All right, I'm going to make a new list just because I don't remember the numbers in their sorted order. So I'm going to make a list of colors. Red, blue, green, yellow. Just so I have some more examples on the screen. I mean, new data. All right, if I want to print out red using indexing, what would I print? I would type out print L at position, and what do I put inside the braces? I want to hear a more emphatic response from a couple of people. What do I put inside the braces to get the first item?
0.
Yeah, 0. If I want to print the last item, there's a couple of ways I could do it. So this is the first item. Let's print the last item 3 different ways. So L sub, what's one way of indexing the last position? Y'all remember that weird little shortcut? You don't use a positive number, you use negative. It starts counting backwards. That's one way. Another is just to figure out what that position is. That's 0, 1, 2, 3. But I don't want to hard code a 3 because what if that list had 20 items in it? They wouldn't be the last anymore. Instead, I'd want to use the length. So print L at position, the length of the L is minus 1. Somebody tell me why I had to subtract 1 to get that to work in order for that to be the last item. What is the length of this list? If I call LEN, how many items are in the list? You're saying 3 because you know how the indexing works, but how many items are in the list?
4.
There's 4. And if you try to access item 4, it's going to crash because it only supports 0, 1, 2, 3. So since the length is going to return 4, we have to subtract 1. Okay, I have totally spaced on the third way to print the last item in the list.
-1. Print -1.
I did that one. Well then, I guess we'll go back to that.
We're missing a bracket on the second one.
Oh, you're right. I am missing a bracket on the second one. I mean, unless it's just hard coding, you know.
Wouldn't be the bracket that would be inside the parentheses.
Yeah, I got those swapped. There you go. And that's why I'm not going to count off big time if you do that on the exam. As long as I see some braces and parentheses in there. All right, so the first item is in fact red, and then yellow, and then yellow. Let's do a wee bit of slicing. We're just going to leave this one blank because I know there's a third way. We'll come back to it. Okay, so I'm going to print the list, but now print just the first 2 items. So I'm going to use slicing. Print L. So slicing means I'm going to put a colon in the middle of it. What number could I use for the first one to specify that I want it to go at the first position?
0.
Yeah, I'm going to put a 0. And since I want 2 items, I'm going to add 2 to that 0 and put a 2. Now then when you start looking up here, well that's 0, that's 1, and that's 2. So you think that that might include green. But honestly, this last number specifies 1 past. So that's why I do the length thing, you know. If it's 2 items starting at 0, 0 plus 2 is 2. So same way, print the second and third item. Print, well, we're starting at the second item, so that's item 1. And we still are printing 2 items, so what number am I going to put there? Starting at position 1 and I want 2 items, what's the second number going to be? I think I heard somebody say it while I was talking.
3.
Yeah, it's going to be 3. Again, all I did is decide what the position of the first one is and then what the list is. Now, if you leave off the number before the colon, it defaults to 0. So if I wanted to print the first 3 items, I could do this. Print L, you know, I'm going to put that 0 in, but then I'm going to delete it. That would get the first 3 items. That does the same thing. Why is that a big whoop? I don't know. I honestly don't know why they put that in there, because it's not that hard to just put a 0 there. What if I wanted to print out everything starting at the 3rd position? Well, I could do that by figuring out the length of the list, subtracting, all that kind of rigmarole. Or I could just use slicing and say I want starting at number 3 and going to the end of the list. So what's going on here? If you do that one, assumes 0 as the first value. What's going on in this one? Goes to end of list. So what happens if you do this? M is equal to list, and you don't specify either value. Well, what does that assume to be?
Everything?
So that's a 0. This goes to the end of the list, so it's everything. That's called cloning, not clonging. Why do you do that? Well, you may have a list, and then you want to do some things to it, like add items to it and delete items from it, but you wish you had a copy of the original data before you did all that. Well, that would make a clone of it. That would make a copy, which is different from doing this. That just makes an alias of it. An alias is like you have 2 signs pointing to the same store. You paint the store red. Both of them are still pointing to the same store. You've made a change to it. You build a second flight onto the store. You pin to it. Well, it's still both the signs are pointing to the same thing. So that's an alias of the list. And I'm not going to use the term alias in the exam, but I just want you to know that. And my usual example of that is, Peter Parker's an alias of Spider-Man. They're the same person. Superman and Clark Kent, that kind of thing. I don't know if y'all read comic books. I don't either, but whenever I read about them, I get totally confused as to what they've done with Superman over the years. It's like there's been 20 different ones. Okay, so in the comics, not the movies. All right, we did insert, I believe. Yeah, we inserted 100 into it. Let's replace. Say we really don't like the color. Where's our colors? We don't really like the color blue. We're going to change it to teal. So L.replace blue, lowercase, with teal. Now let's print the list out. Just make sure that we know what we're doing at this point. And also to make sure at this point I don't have any syntax errors, which I do. List object has no attribute replace. Well, what do you know? Does that only work in strings? That's true. I'm not seeing the error in it. I guess we will come back to replace if we need it. I'll actually be looking at the exam in a minute. Add a new item to the list. The L.append yellow. Puts a new one at the end of the list. So I think we've done everything except replace and min and max, which you pretty much do with math values. You can do it with strings, but it does it in alphabetical order, which makes sense, which is less. The name, Abe, and the name Bob. Abe is less than Bob. but then it gets into a little bit of freakiness because it does it based in ASCII order, where big A's are less than little a's. So I like numbers better for that purpose. So if you do this, let's make another list of numbers, pretty short. 3, 6, 1. And you do x is list.min. What is x going to equal? What's the minimum of the list? 1. And then if you do y is equal to l.max, yeah, 6. I don't even know if I need to do code examples here. Guess I could. If you have a string like this, string is equal to 1, 2, 3, A, and then you print string dot is al num, it's going to check to see if the string is all numbers and letters. And is that true in this case? Yeah, it's all numbers and letters, so that's true. What if you do print s dot is digit? Is it composed all of digits, or is there something else in there? Yeah. So the first one's going to be true because it is all alphanumeric. It is all letters and digits. The second is not true, so it's going to print true, false. And obviously that is not consisting of spaces, so I'm just going to skip that one. By the way, is space checks to see not only if it's a space, but if it's a tab or a character turn, a slash in. But primarily think of it in terms of spaces. What do you know? I flubbed that one. It's not l.min, it's min sub l. Parentheses l. It's not l.max, it's max parentheses l. And you know what? I think I have those syntaxes compared to each other on the exam, expecting you to get the right one. Maybe I'll give you half credit if you chose the wrong one because I typed it up here, but please remember, let's go back up here to our other set of notes. That min, max, sum, and length are all built-in functions. They're the ones that show up in purple, meaning you don't put a variable in front of them. If you put a variable in front of it, it's a special kind of function called a method. Append is a method. You have to put something in front of it for it to work. You have to put the variable that it's supposed to be appending onto. These are all functions, so they all go by themselves. Like x is equal to min, of the list, that kind of thing. Y is equal to the max of the list. Z is equal to the length of the list. S is equal to the sum of the list, that kind of thing. All right, we've made it through my first set of notes. I'm going to eyeball the exam itself, make sure that I haven't skipped something in this review. I think I'm going to stop that. Turns out that I really only ask about 2 ways. So up here,
Finding the last item.
yeah, print the last item 2 different ways. We're just going to change the comment. And how do we do it? Last item's index -1, or you get the length of the list and subtract 1 from that. Forget it. I'm just going to take the rest of the whole thing. Just don't watch the video during class. That's kind of rude. Ranges. Count from 10 to 20 with a range, with a for range. So for n in range, what am I going to put inside the parentheses in order to start counting at 10 and to end counting at 20? Well, I want to start counting at 10. I need to specify an end position.
21.
It's going to be 21 because you go one past the end value. Oh, I forgot to put a print there. All right, now count from 0 to 100 with a range. Two ways you could do this. Three ways, really. For n in range, I want you to start counting at 0. I want you to end at 100, so I'm going to go one past it. That's one way. But you can leave off this number, just like you could with the slicing and the quotes. So you could do this. Why did I do for n in range? Excuse me. For n in range, 101. That's a perfectly good way of doing it. And if you feel like getting funky and putting 3 numbers in here, the third number is the incrementer, the counter. So you could do 0, 101, 1. But let's save that to when we actually need that third number. Count from 100 to 200 by 20s. Alrighty. For n in range, what's the first number?
100.
Yep. Can I hear everybody say it? 100. Alrighty. What's the last number going to be? It's not 200. 201. And the third number is by how much you want to go up each time. Remember that we have a document called the Flowchart Cookbook. I'm just going to point you to it because there are several questions on it on the exam, and you can load it up. I think it was actually back in Chapter 1, excuse me, in Unit 1, so I'll move it to Unit 2. What am I doing? So in the notes for Unit 1, we don't have. Who am I? What? Alrighty. I'll go get it. This is what the Flowchart Cookbook looks like. Tells you the name of the structure and the general shape of the structure. What do I mean? It shows you if statements. Why is that an if and not an if else? Because there's nothing being done if it's not true. So that's just an if. That means that this is an if else. If, do something. Else, if, do something else. Why am I showing you these? Because I show you these pictures in the exam and then just ask you to tell me if it's an if or an if else or whatever. So how easy is that? You go to the cookbook, you look it up if you don't recognize it. This is an if else. If this is true, do that. No? Well, let's check again. If that's true, do that. Else, do that. That's one way to do it, but if you don't like jutting off to the right, the left like that, you could just kind of do it in a sequence like that. It's the exact same thing. I don't remember which one I put on it. You can spot it. While loops. If this is true, do something, and then go back up to the while. If this is an if, you don't go back up. For loops, by the way, look exactly the same. A while with the break. You know, if there's a break statement to cause it to bail out of a loop, then, you know, you don't see anything. While true never becomes false. So there's no line leading out of the diamond except for the true line. But a break will get you back out. And this is what we're going to flowchart today, functions. To call a function in a flowchart, you use the function box, kind of like the math box, but you put vertical bars on it. Or horizontal bars if you can't find a vertical bar symbol if you're using something else other than Lucidchart. And then to define a function, you put the function name up in a circle rather than DEF. I think we're good. So let's write some code with functions. It's not going to be very long code so that we have time to flowchart it. And this is actually our in-class assignment, although you can upload that April code as well. So what this code does, name. And by the way, I've asked a lot that you, whenever you turn in homework, you put in comments up at the top, so I'm starting to count off for that. Just saying. Not a huge amount. Okay, so name, date, whatever. What this program is going to do is it's going to ask for scores. And then it's going to have another function which averages those scores. So we're going to write two functions, one called getScores, but we're going to make it more complicated than just the empty parentheses. We're going to let them pass in the name and the count of the scores. So that, you know, if you say Fred, comma 5, it'll ask for 5 different scores. So that's one of ours. And then the other one is going to be called get_avg. You know, since they have a sum and a length function, I don't know why they didn't just make a built-in function for getting the average. But it's not that hard to calculate. So in this case, you pass in a set of scores, and we return the sum of the scores divided by the average. So those are our functions. We're going to fill them in. But first, I'm going to come down here. I'm going to call this main. We could also just call it start, because that's where the code really starts. It's going to be the first unindented sentence. The way it's going to look is something like this. Scores is equal to get_scores, and we're going to get the scores for Beth, and we want to ask for 5 scores. That's the way it's going to work. Average is equal to get_average, and we're going to pass those scores in. Then what are we going to do? Print average for, comma, oh, this is stupid. I should have actually put Beth into a variable so I could refer to it later. But I didn't, so I'm just going to say average is, comma, and an AVG, like that. That's the way I want it to work, but right now it doesn't do a dang thing because we haven't filled in get scores and get average. If you have to get a series of values and store them in a list, the first thing you have to do is declare an empty list, and then you start appending to it. I am taping now, am I not? Yes. Okay, so here, inside get scores, L is equal to that. That makes an empty list. Now we need either a for loop or a while loop. For loops have shorter syntax. So I'm going to use a for loop this time. For x in range of count, or n in range of count, whatever we wanted our counter to be called. So if they pass in a count of 5, x is going to be 0, 1, 2, 3, 4. Now I don't want to tell them to enter score 0 and enter score 1 and enter score 2 because, you know, most teachers don't start your homework off with 0, unlike, you know, yours truly. So we're going to say print enter score, comma, x plus 1. Why am I doing that? So it'll print out scores 1, 2, 3, 4, 5 rather than 0, 1, 2, 3, 4. Comma, for name, comma, name. That's a long print statement, but that way it'll say enter score 1 for Fred, enter score 2 for Fred, enter score 3 for Fred. And if we had a lot of different function calls, you know, we ask scores for Joe, you know, and stuff like that, it's useful to have the name in there. Now we all know how to get input by this point. So, score or S or something, you know. N is equal to input. N is equal to, it depends on whether we want ints or floats. Floats are safer because they don't, you know, malfunction if they type in something with a period. And now we need to append that to our list. L.append N. Once we're done building our list, so backspace, we need to return our list. So that's the way the functions work. If you put something between the parentheses, those are called parameters. If your function accepts parameters, you have to fill them in with arguments. The same number of arguments is the same number of parameters. So this parameter becomes a variable called name with the value of Beth. This parameter becomes a variable named count with the value of 5. Then we get a series of questions. Am I going to ask you to write this code? Only if I give you flowchart or pseudocode. It's not like you have to absolutely commit it to memory, but I want you to understand it. Alrighty, how do you get the average? If you have the numbers 1, 2, and 3, and you want to get the average, which is 2, how do you calculate the average?
Sum divided by 2.
By 3, it's a length of 3. So the average is the length, the sum of a list divided by the number of items in the list. So average is equal to the sum of the list divided by the length of the list. This is not a terribly good idea if you're not sure there are any scores whatsoever, because the length of the list could be 0. But we're going to ignore that. And then we want to return the average. If your function isn't returning anything, you don't have to put the return keyword. And in that case, it just stops at the first unindented thing. All right, let's run this. Let's call it score list, just to have a name. Run it. Make sure it works. Enter score 1 for Beth. I'm just going to enter, whatever. It blew up. Why? Can anybody see what's wrong with that, what I did there?
You requested the list from one function to another.
Yeah, I pretended that L variable still existed. So since we're passing in something called scores, why don't we just replace those L's with the word scores? Because that has to match that. That has to match that. Enter score 1 for Beth. 10, 20, 30, 40, 50. And the average is 30. That's correct.
What did you change on it?
I'm sorry, pardon?
What did you change?
Right here, if you get an error when you run it, it's because I put scores there, but I put in there and in there. So change those into scores. Excuse me, it was L, not N. Alrighty, anybody getting syntax errors? If you are, what I'm going to ask is that we go ahead and do the flowchart, and then after we dismiss, I'll come back because it won't take long to fix them. Is that okay? Because the flowchart is a really important part of this. So go to Lucidchart. Log into Lucidchart. And I hope y'all will all do this with me. Alrighty, make a new document. Now whenever you have something like this and you're trying to flowchart it, you could decide you want to flowchart the functions first or that you want to define the start, the main first. I'm going to do the main first. So down there on the first column in our flowchart, this is a really short function. We need a start. Starts are ovals. We need a function call. What symbol are function calls? They're rectangles, but they're rectangles with the stripes. So scores equals get scores, but I'm passing in two pieces of data, a name and a count. I want Fred, and I want his 5 scores. And it looks really lousy because it went off the edge of it, you know, and I can stretch it out and all that. The next thing was to get the average. Same kind of shape. Average is equal to get underscore average, and we don't need to pass the guy's name in. I think I had Beth over here or something. I don't know. Anyways, so we're just going to pass in the scores list. Lastly, we're going to print it out. So we know that prints are, unlike math or function calls, are done in diagonals, quadrilaterals, tilted rhombuses. So many different names for the same thing. Tilted rectangle. Okay, so print average. That's enough. We don't need to be hyper-specific in our flowchart. And now, in the interest of time, instead of drawing 3 lines hooking them up, I'm going to draw 1 line, but then send that line to the back. So I drew a line, then I right-click and do send to back. And then I need a stop. Come down here, put a stop. Put a stop to it. There we go. So that's our main code. This bit to this bit. Now let's do a function. This is a shorter function. Let's do it first. Or maybe we should do the complex function. I don't know. Yeah, we'll do the complex function, but we're going to simplify the logic slightly. You could either do a line-by-line conversion, you know, to the flowchart, but flowcharts don't need to always be that hyper-specific. But we need define, get underscores, and then the parameters, name, comma, count. You could leave off the DEF keyword. It would be understood. And not all languages use that keyword. That's kind of ugly looking. There we go. First thing it does is make an empty list. Now in our pseudocode, we were always using the word set whenever we did an assignment like that. I don't care if we really do that or not. L is equal to blah blah. But I'm going to put a comment as what that is. Make empty list, you know. Now we need a for loop. For loops are done in diamonds just like while loops. For x in range of the count. If you wanted to rewrite it, you could say for x equals 0 to count or something like that, but that's enough. Now since we start appending, I'm going to jut off to the right. Oh, excuse me, not appending. Indenting. Since this stuff is indented, I'm jutting off to the right. We need to input a score and we need to append the score. I'm going to simplify this to just 2 statements because we know how to input a score. Input score, append score to L. You could either write L.append parentheses score, or you could write append score to L. You know, a programmer worth their salt knows how to do that in any language. There we go. And then we could send this back up. Once we're done building our list, we can return it. So the DEF goes in one circle, the return statement goes in the other, not circle, oval. Return L. All right, at this point I'm going to maximize it. The last line, the last function was get average, which only had 2 lines of code in it. So define get underscore average, but we did have to pass the scores in. And what was the first line of code of the get average function? It was just a calculation. What was that calculation? Yeah, average is equal to, and it's math, so we're going to do this. Average is equal to the sum of the scores divided by the length of the scores, and then we return that. See, that function's pretty short. And we're actually done with the flowchart at this point. I'm going to make one more minor, unimportant embellishment. Return the average. All right, that embellishment I mentioned is that my own personal quirk is I like to color code it so that when you call the scores function, it's the same color as the def for the scores function, so I use the paint bucket up there. And then when I call the average function, I color it the same as the DEF for that. Why? Just so it leaps out at you. You absolutely know real fast what that one's doing. You don't have to even look at the flowchart to figure it out. Okay. That's our code. That's our flowchart for this. So if I give you code like what I gave you, or what we typed in, you ought to be able to draw a flowchart that looks pretty close to this. You know, I'm not going to make it a far longer program, you know, to make you sit there and flowchart for, 45 minutes. That is going to be the flowchart. And some people were skipping entering it, so I will print it. Who wants copies of the flowchart? 1, 2, alrighty. Alrighty, let's make a Dropbox for this.